right? So, I mean, GraphQL was initially thought of as a problem, and I think me and Varada had discussed long time back in our project when we were in ThoughtWorks, saying that there's got to be a better way because we were doing these microservices, and at that time some parts of it were coming from the DB, some part of it were coming from microservices and all that. I said, okay, there's got to be a better way to actually say, I want a response where I say, oh, this comes from this microservice and this thing and all those things, and fortunately or unfortunately, we weren't that good engineers, and so some other better engineers actually built GraphQL, actually, right? And that's how GraphQL was born. And GraphQL precisely addresses the problem where they say, where whatever heteros wants, right? Whatever API, RESTful API nirvana that heteros wanted to achieve, I think GraphQL has kind of specified that, right? So, as I said, the problem was with specification, right? Not with the technology. And here, GraphQL is a specification. It was originally put forward by the Facebook guys, and I think many groups are now working on it. They have added a whole bunch of it. But the idea is that you have a schema. Centrally, you have a schema which says what are the possible queries you can do to the system, and what will the query return in terms of the object structure in it, and what are the types for each one of them. And it clearly specifies the whole thing. Once you have the query, I mean, of course, no API is read-only. You also have to, write or change something to the API. In which case, you have to do mutations, right? And mutations are basically saying, okay, if you have, I mean, we'll be looking at the GitHub API in a short while, and there we will actually look at examples of mutation, how you can change string and so on and so forth. And internally, they have, so once you have a structure and all those things, they have this thing called the resolver, which will let you say, oh, you want a repository, but the repository has a name and a login, which are this thing. But then you also want to get, a list of all the owners that are there, and you want their favorite languages, right? And then you have to like walk through this graph. And when you say you give a query like this, then you have resolvers at every step for each one of those elements to say, how do you resolve it into the actual object structure or the data that you want. And the subscriptions are fairly new, that I think they got added a couple of months back into the specification, and many of the libraries are catching up to specifications. In fact, the Go library, there are forks of it which have implementations of specifications, but they are not mature yet, actually. So it's not in the main Golang library yet. Yeah, subscriptions are basically WebSocket kind of streaming interfaces into this thing, right? So you want to subscribe to a location change, or you want to subscribe to chat messages for these things and all that. So it follows a very mutation-like API, and you give this, and then you give it an input for it, and then it streams back results that you can get. And again, this is still in flux. This part of thing is in flux. And loaders are like implementation detail, but it's kind of very essential that any real production level GraphQL project needs to have loaders, actually data loaders or batch loaders, both on the client side and on the server side, to actually make it performant. Otherwise, once you put up a GraphQL service and you are naively writing the resolvers, just like how the tutorials tell you, you would basically host a n+1 as a service, actually, right? So where your application will be really slow. So what we're going to do now is, I am very, very light on slides. Most of it is going to be like exploration, because it's a very mixed audience. Some of you have GraphQL knowledge, some of you don't, and there's both this thing. So we'll keep it very fluid, and we'll keep it interactive. So in case you want to ask questions or you want to divert the flow of the thing, we can change that. So GitHub probably is one of the very early companies which actually adopted GraphQL in a big way. So let me guess at, right? Remember this network, hopefully you don't change the password. So I'm going to get rid of this. So this is, I mean, when you're dealing with GraphQL, you usually have this sort of like a query interface called GraphiQL, actually, and you can host it on your own projects. It's, I mean, you just get the thing from CDN and then you just point it to a resource and then you have this editor. Now the cool part about GraphiQL is that you can, like a SQL interface, I'm very careful in comparing GraphQL to SQL, but it's kind of a query language, right? So it lets you write queries and lets you see results and kind of like explore objects and so on and so forth. It's really cool. So yeah, it's yeah. I mean, I don't know what to classify GraphQL as really, right? I mean, it's a sort of a correct, correct, right? So yeah, this has been very hard for me to like slot GraphQL in one of my taxonomies of what it is. So like yeah, GraphQL is GraphQL for now. So let's get to the taxonomy discussion a little later. Uh, All right. So every GraphQL basically starts off with a query, right, and the word query. And I'm already signed in, so I would say I am the viewer, and I'm going to since I am this object, so I need to know what I can support actually. So query.viewer is actually a user. You see this? Maybe I should do this. Query.viewer is actually a user, right? So a user, I know, I mean, obviously ID everybody should have. I'll also have a login actually, and I would have a list of repositories, but I'll get to that. So let's do this simple query and say I'm already logged in, and then I should have my ID and login. So let's run this query. So you hit the play button, everything works fine. I say okay, this is my GitHub ID, and this is my, I mean, their internal database ID of some sort, and this is my ID. Okay, now I'm interested in looking at my repositories, a list of repositories, and the repositories here says that you need to say how many repositories do you need to fetch actually, right? So this is basically for pagination and things like that. So I'm going to say I'm going to get the first, or I'm going to get the last 10 repositories. Okay, I'm also going to get the total count of all the repositories that I have. And I'm also going to get the name, or I'll say name with owner, and it will tell me all the repositories that I've recently worked on or touched, right? So the last few repositories that I have. So this is basically all the stuff that I've been working on, which are public, which are there, right? I could also say I don't want, so I see some of them are like Tarka Labs. I don't want repositories that are from somewhere else. I only want my repositories. So I could say affiliations is owner actually, and I say if that is the case, then I can basically get only my repositories and things like that. Right now, these are parameters that are passed to this object that we can then do this. So the resolver function for the repositories would then know what to do with it, right? So it's a now. We can make it a little more interesting. So within these nodes, I can actually look for contributors or collaborators, and for these collaborators, I can again get so the list of collaborators is actually no users, actually a list of users, and for each one of them I can get this. So in this case, what I'm going to do is okay, let me run this query. Okay, you said first and last values. Again, I'll say first 10 of them. I mean, mostly they are my repository, so only I would be the coordinator on this. So let's make it a little interesting. So we'll name this query. We'll name this query my repos. Okay. So let's have another query, and we'll call it org repos. Okay. And instead of this viewer thing, I'm going to have organization. Right. And I'm going to query with that. Hopefully this should work. So the org repos, if you see, it's a little more interesting. Now we have a whole bunch of collaborators that are there and so on and so forth that are displayed by an organization, right? So here you can name queries and you can do this. Now, anytime you want to know what this organization actually is, you can do a command click on it, and it will actually come up with the organization detail here, right? And say this is an organization, and it will say it implements node, actor, project owner, repository owner. So these are interfaces actually. So GraphQL not only allows you types as in int or string or things like that, or time and things like that. It also allows you to write interfaces which you can do that. Now we will be working with the schema, so we'll be using an example and we'll work with the schema very shortly. But so these are queries. I also want to show one example of a mutation actually, how you can do a mutation on this. Now, but if you can see with this, this sort of an example, it's really easy to compose these queries, right? And I mean, if you had to write, I mean, GitHub has a REST API as well, right? And it has this repositories endpoint, and it has this repository /id /collaborators endpoint, and this thing, and so on and so forth. So it has all these endpoints. So if you as an API, I mean, someone who's consuming this API needs to use that, right? And they followed the RESTful API thing, and they have done this whole thing, and they have all these resources and all that. You would make multiple calls to the API to actually fetch the kind of information that you fetched here, actually, right? And that would actually cause a lot of strain on their servers, because if someone is using their APIs and things like that, so they would have to rate limit them and so on and so forth. Here, you know, I mean, arguably server goes to the same string, but then you have much lesser round trips between your things, so your applications will be more performant. And they don't have to worry about tailoring these APIs depending on what the customer wants. The client can basically decide the shape of the data that it needs. Okay. Now this is a very important concept, because say in a page, right? You have in a complex web app, you have some sections asking for some sort of data and some other sections asking for some sort of data, and each one of them is making these queries and so on and so forth. You can have a layer in your application which can take these GraphQL queries that are going to go out and compose them into one big query and send it to the server every request animation frame. So within a request animation frame, if you are going to make a request, okay, it can collect these requests within this request animation frame that are happening and make one call, actually. And there are libraries in JavaScript, like the Apollo client library in JavaScript, which does that. And Relay has another implementation which does it. Relay is a project from Facebook as well, and so on and so forth. So this is extremely powerful, and especially with the new age, single page app sort of thing. I think GraphQL is a much better interface than REST is, actually. Okay, let's do one mutation, actually. So I'll call this star repo. I mean, so I'm going to take one open source repository and star it, actually. So for which I'm going to look for a repository. Yeah. So mutation is something that you change, actually. So query is what you query. So it doesn't change any values. You're just querying GitHub to get this thing. Mutation is something that you're going to change, right? So I'm going to star a repository, right? So yeah. So it has a list of mutation types. So if you want to know everything that this supports, you can go to mutation, and it says these are the kind of mutations you can do, actually, right? And the cool part about GraphQL is that the schema is introspectable. In fact, that is how this tool even gets it. That means that you can have your client tools generate code for you. Right? So you have a schema GraphQL and you point it to the endpoint and you say, I'm going to consume this. So you can let your client, Android or iOS client or JavaScript client. Actually, for JavaScript, you don't need it much, but the Android and Swift can actually generate code for you, and then you can use those. Yeah, you have autocomplete and essentially a fully typed experience. Yeah. Yes. Yes, SOAP is the thing is with SOAP, your contracts are well defined, and your response is only what you would end up overfetching data, right? In a sense, and it has a very similar. I mean, so it's kind of an RPC with an envelope, right? Yeah, with an envelope. So here, it is not an RPC, right? It is still giving you a resource-oriented view of the world, actually. So the mutations, you can argue that they are kind of sort of RPCs, but even here, that is not strictly true. We'll get to that shortly, right? So if you are looking at this, so it gives a very resource-oriented view, and you can actually just fetch the kind of data that you need from the resource.
So the service, the graph API server, right?
Yes. ask for. What you ask for. So there is no problem with overfetching or things like that actually.
And so, what works? Is there any convention that the graph will follow saying that mutations are always post or what HTTP works they will do?
So the beauty of this whole thing is that there is only one endpoint. Okay, we'll come to that. We'll come to the actual implementations here. Okay. Now, if you look at the add stars documentation, it says that you need an add star input actually, which is mandatory. The bank basically means that it's mandatory, and this has a starable ID and a client mutation. Okay. So before this, I'm going to make one query to actually get the ID of a repository that I am interested in actually. So, any of you, any Kubernetes fans here? Kubernetes fans? Okay. Cool. Rancher is awesome, by the way. You guys should check out Rancher. Okay, so I'm going to start Rancher. Okay, so I'm going to say if I have not already started, so let me do that. Rancher RK. Have I started? No, I haven't started yet. I just want to make sure that I'm actually hitting the GitHub thing.
Will still say that like no, I cannot mutate because it's all there will be some validation even if it's start.
Oh, that's a good point. We'll check that actually. So let's see. I'm going to say I want to look at the ID of this guy. Okay, so I'll just run this for star repo, get the ID for this. Oops. Oh, I think oh, this has an error. So let me. Okay, so I got this ID. So this is what I'm interested in. So I'm going to say mutation star repo. I'm going to say I'm going to actually add star for an input, and starable ID for this is going to be this. And this also has one other input. Actually, add star input has one other thing which is called, I think, client mutation ID. So client mutation ID is basically a reference parameter that we pass. Could be anything, right? It's just a value of mutation input. And this will give me back. So the add star will give me back an add star payload, which will have a client resource ID and starable again, actually. So ID and viewer has started. Okay. I'm just going to get that. Okay. Now, so let me run this and let's see what happens. Okay, so it has given me this and it says I have started this actually. So if I start it again, so let's refresh it to make sure that I have started this. I think for the sake of the demo to have its impact, I think we should go and verify. Yes. Something wrong with the Wi-Fi? Whoops. This is a little anticlimactic. This is the advantage of rolling chairs. It should work now. Okay, yeah, it doesn't matter. So let me connect to my Geo to find out if that works. Oh, it works. Okay, I have started. Yay, okay, right? Yay for us. Actually, so we have, right? So, so if you find out this is a starable, right? So it's a starable, but it doesn't give a lot of input on what we want. So we have started, yes, that's cool and all that. So if I run it again, okay, start repo, it doesn't give this thing. It says, I mean, it's an idempotent action, I guess.
I think that's the contract.
That's the contract. It's the idempotent action. Okay. Now the cool part about this is, I said starable is an interface, right? But then you could, I mean, you could have many things that you could star on GitHub. Repositories and gists, I think, right? Those are the things you can star on GitHub. So now I could say, okay, if this is a repository, okay, if the resulted star is a repository, I then want the name, description, owner, languages. Okay, for the owner I'll get the, so this is a user, so I would have a name here, login actually, and I want languages, first 10 of them, with nodes having name. Okay, now this is the beauty of it, because it is returned as starable. So I mean, like, this is very hard to do on a typical thing. Now if I run this,
How do you read this? So, if star it, if it is a repository,
yeah,
return, or star it, irrespective
so
of
it'll star, irrespective, you star it and it returns a star.
repository, return.
Yeah, only if it's a repository, include these fields actually, right? So just, so now it's run star repo again, and so it gets, oh, this says make file go and shell in here, and it has the name and description of it. It's really cool. I mean, this is really hard to do in a REST API, right? And if you, because you will have to think about all of the clients, possible use cases, and you have to cover them and all that. And it's almost a query language, but you have to be very, very careful about calling it a query language, right? It's almost a query language. Okay, cool.
So can you join name the variables? Can you use name variables inside?
You can create, you can declare fragments and use them. So for example, you could say fragment I think
You will take part of the
yeah. So let's see. Yeah, it is not happy. You can give a fragment. I'll get to this thing. I forgot the exact syntax of the fragment, but you can actually declare a fragment, and just like how you do this, like at this point in time, if you want name and description, you can say a dot 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 fragment actually, and then it will expand onto the value. I forgot the exact syntax for how to declare a fragment. Right. Okay. So this is about GraphQL, and this is about how this thing works. Kind of like a 20,000 foot view. Any questions or anything? Because in the next part, if you move, I mean, you should be clear about this. I'd be happy to answer any questions that you have at this point. Are you guys suitably impressed for this? Yeah. Sure. Yeah. So yeah, good point. We'll segue on to the next one. That's an excellent question. Yeah. We'll get to that. We'll get to the implementation very shortly now. Okay, on to this thing. So I'm just going to take up a Golang code base and walk through this thing. So how many of you fans of Star Wars here? Okay, others of you tough luck. That's the only example I have. Okay.
So then first, Star Wars story.
Well, it's kind of a movie that they made 4, 5, 6 first, and then they made 1, 2, 3, and then they made 7, and then they made 3.5, and then yeah, yeah. Right. So let's start with Star Wars. Okay. Now, yes, a galaxy far, far away, right? So the point is here we have a query. Now, actually, so we are in Golang world and we have this thing. So what I'm going to do is, for the sake of readability, I'm going to take everything that's there in this string. So those of you who know Golang, it's basically backtick is like a multi-line string. So essentially they have copy pasted the entire GraphQL schema into the source code. This is obviously not the way you should be doing it. You'll in fact, you see another example where there's a slightly more complicated version of this, where we actually have a way to compose these things and all that. But for the sake of readability and like syntax highlighting and all that, I'm going to take this and write it into a different file actually. Right, and I'm going to say okay. So every schema starts with a query and mutation. Okay, this is kind of the default. If you have subscription, you would then have a subscription here, but Golang currently doesn't support GraphQL subscriptions. It's there in a fork. It will land shortly actually. So you have a query and mutation. So let's look at the query object, right? Query, you have hero actually, which basically says, give me a hero for an episode. Sure, sure. So you have a query which says, okay, I have a hero, or I can have reviews for a given episode, okay, and then it'll give me back a list of reviews. I can search for something and it gives me back something called as a search result. I can search for I can look up a character, I can look up a droid, I can look up a human, and I can look up a starship, actually, right? So, I mean, droids and starships, droids are like robots in this thing, and starships are starships, and they play a very important role in the Star Wars universe. Like, for example, anybody who knows Star Wars knows the Millennium Falcon, right? Those kind of things, or the Death Star, or R2D2 and things like that. So, anyway, so let's go to the episode, right? And episode is kind of an enum actually, and so this schema is basically there to say, okay, different types you can have and all those kind of things. So episode is an enum, so you could have a New Hope, Empire, or Jedi actually. Like I said, the other three Star Wars movies that are made later, part 1, 2, 3, yeah, they're horrible, right? So New Hope, Empire Strikes Back, and Jedi. That's the Return of the Jedi. That's like the Star Wars trilogy that we care about. And then you have an interface called character, right? Now, so we don't have this thing called character, but we don't have a type called character, but we have a type human which implements the character later, because droids are equally important. Sometimes they are the hero of movies, right? And we want them as characters. So we have an ID, name, and we have whom they are friends with, how they connect with them, and which episodes they appear in, actually, right? List of this. And we say this is a human, and human basically implements a character. That means that all those values that they have, I mean, ID, friends, all that will be there. But in addition to that, you have height and mass, actually, right? But everything else, and they have starships, actually. I don't think Droid has starships. Yeah, Droid doesn't have starship, but this has starships. So if you notice here, we are repeating these values. So we are not implicitly saying that you get these things from there. So it kind of, I mean, I'm not very happy about this, actually.
What if you skip the would it complain?
It complains.
Then what?
So this is basically for the type system to say if you get a character, you can also get this thing done. But the resolver needs these types to be present. So again, Droid implements characters. It's pretty much the same thing, but Droid has another primary function. That's the only thing that the Droid has in addition to that. Again, we can go through all these types, but not really, I mean, all of them. We'll actually explore them in GraphiQL, which would be a little easier way of doing that, actually. And we have a mutation as well, so let's look at the mutation. Mutation allows us to create a review. You need an episode, and you need to give a review input, and then it gives an output of a review. So let's look at what the review input is, actually. Sorry. So I don't have the tooling for this. So a review input basically gives an int in terms of stars. You can give 0 to 5, and you can give a string which is called a commentary, okay? And then it's going to return a review, which is again going to be a list of stars, and it's going to give a list of reviews for a given movie. So let's get this thing done. Okay. Now that we have the schema, so as I said here, this file has the schema, okay, and then it right now you talked about the database aspect. How does it connect to the database and write all that? right now we have it in memory actually. So if you want to connect to the database, you can always connect to SQLX or whatever database value and to do that. So the important part is the resolver. We'll get to the resolver and I'll show you that. Okay, so this only has data, right? You have to trust me on this, or I'll give you access to. I mean, the code base is there as a part of the GraphQL example. This basically only has a list of all these structs that are there actually, and then you have a map of these structs which basically give the IDs and all those kind of things actually. So that's pretty much what we have. All there here in this thing. So this is the interesting bit. Okay, so we have something called as a resolver. Now resolver is basically a struct which is an empty struct. You can have it initialized with, say for example, you want to connect to the database, you basically want a database connection object in there or something like that actually. And then for each one of the types that is there in the GraphQL, right? Say for example, hero type. Okay, you want to then give a resolver for this actually. Okay, now the thing about what we need to see here is that this needs to be an exported symbol, so from the package, so it needs to be capitalized. Okay, so even though the query here is called hero in small, you want to call it hero in caps, which also suggests that the resolver package uses reflection to actually map these values. Okay, so you don't explicitly have to bind hero to hero. So if you have the same name resolver in there, it will automatically get resolved actually to the root. Right now, the resolver has an episode, and then it returns a character. Right. So since it returns a character, we are going to return a character resolver. Okay. Now the character resolver can basically return. So it implements the character interface basically. That's because the interface in in GraphQL is character as an interface. So we implement the character interface, and then within that we actually have a human resolver. So let me walk you through this one more time. Right. So you have the character resolver, which then gets a human resolver and the human data. And this is a map, right? So once you have a human resolver of what that data, it knows that there is the human which it needs to. So, but we are just nesting resolvers in there. So you have one resolver and then we are nesting resolvers. Similarly, review resolver. So given an episode, we want to get a list of reviews. So we actually find a review resolver, and for each one of those episodes, we actually tag a review resolver actually. Now this resolver will get called depending on what fields it needs to get into. Okay, so let me just show you how it works in practice, and we can go back. So the server.go is pretty simple. So it has this GraphQL package that is there, and you get the GraphQL Go actually gives the schema package in here, and when the package inits, we actually say must parse schema. So you also have a parse schema method which won't panic if I will only give an error back if there is an error with the schema actually, and then we pass in the resolver. So, and this is how you do it for all schemas. So you have a schema and then you have a resolver tied to it. So which says, okay, the schema is basically like a tree of nodes, and then you basically say, oh, how do you resolve each leaf or node in the tree actually, right? And then once you have the schema, we have a query function. The query function basically handles the schema. Okay, relay is a library again by Facebook. They have implemented relay here. So you can say relay.handler, which basically takes this, runs the query, ties up with the resolver and gives you. Okay, and relay is not that hard a library. I'll show you another implementation, a little more verbose, but you can essentially implement relay in probably 100 lines of code, 100 200 lines of code actually. So relay is pretty straightforward. And so this is your normal HTTP, net HTTP sort of thing, right? So you have this. So answering your question, all of them come to the same endpoint. Okay, there's no get dot. Everything is post.
It's always
Yeah. So the point is HTTP is an optional transport layer, right? So in a sense, it doesn't. GraphQL doesn't specify a transport layer, right? So we just say, oh, HTTP is convenient, so let's do that because browsers speak HTTP. Right?
You can't use any verbs.
Yeah, you can't use the RESTful verbs. You don't need the RESTful verbs.
Then, so we'll lose the whole node in it.
We'll get to that. We'll get to those things a little shortly. Yeah, you will lose all the HTTP layer benefits, correct? But then you have those patterns implemented in GraphQL. We'll talk about it when we come to loaders, actually. And then finally, here we have a slash endpoint here, and all we are doing is we have this again HTML pasted into the code base, so convenient. And this is basically the GraphQL thing, right? So,
Query
uh,
endpoint only hosts one particular string.
yeah,
Can you have multiple points
no, you cannot have multiple schemas in an.
in a particular? For example, you have query one
Uh,
one schema, query two another schema. Is that possible?
no, you can host only one schema in a. I mean, so with relay you can only do that. But I'll show you another example where we build something like relay and we can do other things. Okay. So here it's pretty simple. GraphQL is basically a React library. So we get GraphQL, we get React, React DOM, GraphiQL, and these two are basically polyfills for fetch and promise actually. So we are running on Chrome, so that's not a big deal. So we then, in this thing we actually create GraphiQL and we pass in a function to this called fetcher actually, right? And we have one div ID GraphiQL, that's where it gets loaded. And fancy units, 100 view heights, right? So, uh, so here in the graphical fetcher, we say these are the GraphQL params that we get actually as a part of the post, and we are going to do a slash query on that, and if it is there, then we return the response body, and if it's an error, we catch that, and so on. And this function basically, so once you write it, in fact, when you write your own GraphQL servers, probably this is the endpoint that's going to change, but this file is essentially going to be the same for you, actually. And that's about it. So let's run this starwars.go.
But there's a button, you can also change the method. It has an option to change the method post. You have to find it. You have line 44.
Yeah.
So it's
I mean,
not
if it
always-
yeah, it's not always the thing, but post seems,
Because you have mutations.
yeah. Not only that, this query is going to be pretty huge.
No, but
You
I
need
mean,
to
just
pass it in
see
body.
No, there's a switch. I mean, you can decide.
Yeah, you can decide what you want to do. Yes. Like I said, the transport is entirely configurable. So, okay. Yeah. Okay. Yeah. Okay. Localhost 8080. Okay. Yay, we have the thing. So let's look at docs. We have a query, and we have these types that are there. Pretty neat, right? So now let's say hero of say episode. Okay, we'll just get the query. Query needs to be the top level object. Right? So hero gives me a character, so I should have a name in it. Let's say new hope. Obviously R2D2 is the hero, right? Because it pilots this thing along with him, and it. That's because we have this one hero.
I think hero always will come.
Yeah. So otherwise, there's only one hero.
So default is hero.
Yeah. So this is an enum. So either it's Jedi Empire, or this thing, right? So Empire is Luke Skywalker, Return of the Jedi.
But I cannot
Yes.
get all the heroes like across all characters.
Can you get all characters? You can. I mean, right now this particular thing doesn't have that. I have another example with SW API. How many of you know about the SW API? Yeah, it's like a very useful API for demos. So anyway, okay. So this is this thing, and then if you look for reviews for an episode, which one? I'm sorry.
Hero, I mean, just
You pick the same character or a human.
instead of hero, you get human.
No, but if you do human, you have to give an ID actually. Yes. Yes.
I mean, the
So
schema is
the-
not designed for it.
yeah, so like the schema that you have written doesn't support it. That's where.
Still, like, it's
Yeah, we still have to. See, this is the thing, right? So I feel writing a GraphQL schema requires more thought than writing a RESTful API. I mean, or at least as much thought. It doesn't make the job of writing the server easier. It makes the job of consuming it easier, actually. Writing is about as hard, actually, right? So okay, so you can do search, and you can say text, uh, D2 should be a case insensitive search, and let's see what's there in the search result object. So these are possible types, actually, human, droid, and starship. So I could say if it is human, then I want it to give name and appears in. On starship, I want the name again, and if it is actually on droid, I want the name and its function. So let's see. Yeah, let's look at the search implementation. Yeah, let's see what it searches actually. So, starwars.go. Let's look at search. Does the range of humans contains arg.text? Yeah, yeah. So yeah, so I have to say, yeah, right, right. So if I say R2 is astromech, actually, and if I say Falcon, and I just get the name. So the shape of the thing changes based on the kind of thing. Yeah,
So it's relay which wires it up, right?
correct. Relay wires basically how you actually take this query and how to run this.
So how would it know the connection? Say primary key equal. This is connected to other object.
It doesn't know.
It doesn't know.
It doesn't know. See, why should it know?
Okay, say for example, go back.
All your code is in the resolver.
Okay.
It doesn't care about primary keys. It doesn't care about any of that stuff.
Then, say for example, in this resolver, right?
Yeah.
Say humans might have some 4 different objects, and I should write a resolver for the 4 possible things that could come inside humans.
Exactly. So when in a human resolver, you have the ID, name, height, mass, all that. For each one of them, you actually write your resolver. So if this actually returns another, say this thing, object, you will then return a resolver.
There should be a resolver mapping to that object.
Exactly, exactly. And that would then have this parameters which then go down.
All the way down.
Yeah, yeah, it's resolvers all the way down, actually.
Parallel trees, resolver tree, and your object.
So your schema tree, for each node and leaf in that, you should have a resolver. Pretty simple, pretty straightforward. Actually.
What's the definition of search result? Not the function.
Yeah,
The return.
yeah. Good question. It returns a search result resolver. Okay, so the search result resolver returns a search result actually. Yeah, this result you won't see it here in schema.graphql. Search result is basically human or droid or ship. It's in this thing union type. Neat.
Yeah. Wait, what does Go and do?
So yeah, in Go it just returns an interface. You can't handle it. You'll be like, born of this. So that's why you do a 2 human, 2 droid, or 2 starship. And then you do so when it is one of those 3, then you actually then turn it into a human resolver or a droid resolver or a starship resolver. Huh? Yeah, so in a sense, yeah, it does in, like I said, it's writing GraphQL APIs is a little hard. I think, so I actually planned for like a live coding sort of session initially. Then I felt no, I mean, I think I'll lose a lot of people in the process. So I thought.
So I think the aim was mainly compared to this to reduce the network traffic.
Yes.
That was the aim.
Correct.
So to minimize instead of getting the entire data. So they were going to make it easy. I think the aim was when you're using data over a mobile, mobile device, you
Exactly.
need to reduce the data that remains.
Number of round trips mostly.
Yeah, that increases latency.
Correct.
And also the processing time.
Correct.
Also, it's like this, right? It's too little or too less data. You cannot ever get that.
Exactly. So
allows you to exactly just fetch what this one specific or type of, just that piece of data that you want.
correct.
That was the aim.
Correct.
So as a consumer, I'm very happy, but as a creator, is what I'm
Yeah. I actually found a project that I was working on that I was looking for. This has an error actually in it. I'll show you how it works actually. So I honestly I didn't introduce the error. It was there before. Okay. So
That's what we keep testers.
okay. Okay. So here I have this thing called user. So this actually connects to a SQLite database actually. So this is users and pets. Okay, and then a pet has an owner and things like that. So so the query works a bit like this. So you could say I want to say get user. Now if you see again, this is a horrible way of writing. I mean, at least I found this shouldn't be the way in which you write the API because you could just say users instead of saying get user. Okay. So once I have the user, I think I can get the name, and I should get a list of pets. But anyway, let's get there. Now, I think I should actually have pets itself. Yeah, I have pets. Yeah, I have pets also. Right? So I can have name and owner, and name and ID. Right. Now, if I have okay, so I got pets and I got pets as null because the resolver actually failed at that point in time. So it says pets is null, and it says GraphQL panic occurred runtime invalid memory address nil pointer dereference actually path get user pets, right? So that's the path it was trying to resolve, and it failed there. Okay, let's find out what happened. Right? And so this is where the fun part comes. You get to read stack traces, right? Runtime panic go, scope go, association go, users go 39. Okay, that's our code base. So that's where this would have happened. So let's look at that. Users go 39. Okay, okay. So now, so here again, so this is another weirdness in these resolver methods is that now they are using pets actually for the user resolver. They are using capital pets. That is because of GOM, because GOM also has pets. So, but the reflection code that I then looked at the reflection code in the resolver. It's smart enough that it does a case insensitive thing for the pets to resolve. It's a little weirdness going on here, but ignore that for now. Assume that that's the right code, right? So they are getting get user pets, and the way they are getting it is they are actually getting the context and in32. They are returning an array of, I mean, pointer to a slice which contains pointers to pets. Very bad. I mean, this is how you should not write Go code, by the way, right? And then you don't need a pointer to pet. You could actually just have a slice of pets, actually. So you could do that, and then they're actually doing a db.model user dot association pets, and then say find p. The point is they haven't qualified the user. It doesn't say which user it needs to find an association to pets, and that's the reason why it is failing on the associations layer actually, right? So simple enough to fix. So do this. Let's get rid of this whole thing. We can directly query pets actually, and we just have to find out the owner ID. I know for a fact that it has an owner ID, and that's about it actually. And we'll pass in the ID, which is there from top.
You don't need that star, like star, array star.
Yeah, you don't need this either. Yeah, you don't. Let's see. Yeah, that's it. Right. So this should work. Let's run this again. Oh, this needs to be a pointer interface. I think this is because of the GraphQL madness. Okay. Let's run this again. Forget this. Yeah. So ID, list of pets, owners, all these things, right? Now the thing is that let's do this. So every time we actually find the user object here, so if you find here, many of them are the same user, right? So Alice has Rex, Goldie, Spot, blah blah blah, right? Now let's log every time we call the user resolver. Okay. Whenever we make a database call, let's do that. Yes. So from pet model. Huh? I know that, but I just wanted to enable it in this. But I want to show how many calls this particular function gets actually. So I think it will be pets.go. Pets.go would have the owner, the db.getPet owner.
In the other Star Wars example, you had the implicit calling, like maybe starting instead of that, you had resolve star resolve.
But there was no maybe.
There was no resolver, so we just had to just return a resolver, and within the resolver struct, we actually did this. Yeah, there's this data inside which is.
So resolver can be anything.
Yeah. So here. So okay, let's run the query again. It worked. See this? So it's a classic n+1. So it's just same user actually. Right? So this is kind of embarrassing, right? You shouldn't be doing this actually. So we know it's for the same ID, and so we need to do this. And if you have again within here, we'll do one more level. Yeah, and we just give name actually. So it should still work, but let's see. So we'll say get pets. So this should actually return a bit, right? So now if I run this, like I said, this is a very naively implemented this thing. So it does it. So it fetches all those users, and for all those users again, it fetches those pets for the same user ID actually. So it's a very naively implemented GraphQL server. So if you write a GraphQL server like this, then you are asking for database performance troubles actually. So in order to solve this problem, Facebook actually, I mean, kind of wrote about a pattern called loader, and they quickly open sourced the data loader actually, and that was a JavaScript project that they had, which basically implemented this one thing. They said, okay, I will, for each one of the resolvers, you will ask the loader to load this, okay? It will basically then fetch all the whole thing, and then it will get a list of all those IDs, okay? Make one call to the database and say, where ID in all these things. It will fetch all those things, and then it will resolve here once the database call is resolved, okay? And it will only resolve when the whole, query is going to get returned actually. So I don't have a working example for this database thing, but I do have another server. So let me kill this. So this again uses the Star Wars API to work with. So let me open this. I think it's running on port 8000, if I'm not mistaken. Okay, yeah, this is running on port 8000. So this doesn't have mutations at this point in time, but yeah, so this will give me a list of films and all that. So let's get a list of films. And let's get the episode, and now this is actually going to make a call to the SW API and get that. So I think we should have a title as well. Yeah, I think it's just episode 1 word. It doesn't have that. So it even has the opening crawl. So this is like the iconic crawling text. It says, it's a period of civil war and all that. So this is like all that. And what it also does is you could also so here let's do something interesting. So let's get characters, and we'll get all the movies that they participated in, episodes they participated in, and we'll get uh, starships and all the films that they participated in. And here we'll again give the episode. So this is going to make all those calls, but I mean, in a sense, this has a loader implemented, where the loader has a batching function, which basically takes that and gets a list of all these things. But let me show that. I'll also give the character name. So know what we're talking about. Those is actually calls the Star Wars API. You get the swapi.com. So so this has Luke Skywalker, and he participates in like pretty much all the episodes except the first two, and then you have C3PO, which is throughout except for the seventh one, and so on and so forth actually, right? R2D2, Darth Vader, Leia, and then you also will have it for the vehicle Star Destroyer and and yeah, you have all the destroyers and which films they participated in, so on and so forth. So we have all these things. Now let's look at how they have implemented the loader. So here it is a slightly more a realistic example of a GraphQL API. So if you are writing your GraphQL API server, you would probably follow something like this. So here they have independent GraphQL files actually. So you have a schema.graphql, and the schema.graphql has a query, and then you can also have one for mutation. So in query you have a list of films, people, planets, species, and for each one of the films you have a film.graphql, and then you have a person.graphql, planet.graphql, and all that. So there is no fancy parser or anything. So they have this schema.go, and then they have this go generate statement. You guys use the go generate statement before, like bin data or this thing. So what it does is that you can you could do go generate, and then it will run some command to this. And here they're using something called as go bin data, and they're taking all those assets and then they're packing it into one string file actually. And they have this one command called string, which basically ranges over all the asset names, which is basically all these query names that they have, and they just append it all with a new line character here actually, and that's about it. So essentially it is the same as pasting the whole thing in one string. So this returns that string, it returns that schema string essentially. That is the only difference between the previous example and this example that we saw here. And what this allows you to do is, I mean, from a version control perspective, you can keep changing one by one, and you don't have to keep editing the same file, and you have syntax highlighting and all those kind of things. If you have it as a string in Go, you may not have that actually. Okay, so in server.go, we have a client which is the Star Wars API client, and this is pretty straightforward. It actually knows how to make a request, and the Star Wars API then says, okay, how to make a request to you know, backend stuff and all that. This is not interesting. You may replace it with your database layer, what have you, right? And then when they create the server, they actually create another resolver, and they pass in the client to that. Now the resolver basically now gets a list of all the clients. So let me go to the resolver. So this is going to be a little dense actually. So the resolvers have, so let's go to query.co. So the resolver has this new root, and you have the films query, and the films query then has a way to search for films with the title in here actually, and it will return a bunch of new films actually. Now after it returns those new films, then it loads these you know, has this loader, and it calls the loader to load the films actually. Now this loader is a part of the data loader API actually, right? So it's a redirection to the data loader API. So let me go to the declaration here, and this allows you to you know, it's written in a little verbose way. I think it's very hard for me to just do a code walkthrough here, but the idea here is just this one function where you have this load batch function actually. The load batch function basically takes a list of keys, the data loader keys, in which case there are you know, different values, and it then provides a list of results, right? List of IDs to list of results. Then you could do an inquiry on a database or this thing. It done, right? So that's, yeah, that's the. So that's the idea. So the idea is that now you go through the loader. So anytime you do a resolver, the resolver then calls a loader. Loader then basically gets a list of all these IDs. It makes one call to your backend. In this case, it is making multiple calls because it's still HTTP API, and then returns all of them. So you can use this loader layer for all your caching and all those kind of things. I'll give in the interest of time, I'll actually send the URL to this code base, or we can take this offline, and we can probably do a deep dive into this. But it is a little dense, this particular thing. Yes, and also a little scary. So, any questions? Any comments? Yes. Yeah.
Let's say, for instance, if the person is from QT or from the upstream, he might be, whenever we use REST, we use the post. Is it, are the person supposed to know how this query to?
So they can use the graphical interface. So graphical interface is something that.
Has to write this query, this must take.
Yes, pretty much. So in a sense, they will not test your endpoint. So your endpoint testing, I mean, okay, let me put it in this perspective. Right? So if they have a postman collection to do all those kind of things, that is probably because querying that is hard, right? And you need a tool like Postman to do this. Here, you have the metadata, you have all those kind of things here. I would argue that actually querying GraphQL backend endpoint is actually simpler than maintaining Postman collections and those kind of
But you
things.
still can use Postman to make GraphQL queries, right? At the end of the day, it's anyway the same Most body will have this.
Yes, yes, yes.
You can just send it.
Yeah, but that's not what Postman was.
No, no. Think about it this way, right? So there are so many scenarios. Usually, a QAs will be interested to know that all the scenarios work.
Correct.
Meaning, if I nested in this way, all the results are properly resolving or not.
Correct,
Then
correct.
I could have a connection to say different combinations.
Fair
Then
enough.
manually, if it's tested, we can run that.
Fair enough.
Postman.
Fair enough. Yes.
But then that's when to unit test them.
We should not use this. I mean, no one is saying no to this, but at the integration level, I would say it takes an
Okay. Right. Something else? Yes. Yeah, so this is the loader layer. Loader layer is where you do the caching. Loader layer is used. I'm sorry? On the HTTP layer, you don't have caching. That's what I meant. So you pretty much those things go out of the window. You replace all those things either in the client side. So there's this Apollo client library, right? And you can implement client side caching there, or on the data loader layer you can have your server side caching. So you can do things like LRU caching there, or you could do have your full-fledged memcache layer there, and so on and so forth.
But it's still with our machines, right? This is the category network. I don't even worry about getting to find it.
On your API, I don't know if you would want to point it to a CDN there. You probably don't want to.
Yeah.
You don't usually cache your API questions.
Yeah.
API is very dynamic.
I mean, yeah, I can technically by some.
Yeah, so you don't. So like I said, HTTP layer here is. I mean, it so happens that we are using the transport layer, but GraphQL specification doesn't really say you got to use HTTP or anything. Anything else, guys? Or? I'm sorry, for? For beginners, I would say stick to the JavaScript side. It's much easier. Once you understand the GraphQL concepts, then translate it to Go. Actually, I would suggest that. Get started on the Node.js JavaScript side first.
It's much more mature, right?
It's a lot more mature. And there are a variety of libraries. I think Apollo is something that I would strongly recommend, both on the server and on the client. It's one of the implementations of GraphQL. Cool, guys. All right, thanks.